All right, hey, today we're going to be talking about a lot of probability information. So we have set theory, Venn diagrams, counting principle, and basic probability. All right, so first off, we're going to talk about sample space. So sample space is just all the possible outcomes of an experiment. So in this case, you have 2 coins are tossed, and this represents the sample space. So here could be your first coin. You can either get a heads or a tails. And then depending on if you get a heads with your first coin, you could toss either a heads or a tails. Or if you do a tail on the first coin, you could get a head or a tail on the second coin. So these are all the outcomes that you would get depending on which direction or which side of the coin that it lands. So that's just that. So your sample space, we usually write it with whatever we're looking at, and then we put these little braces here, and we put all the options for outcomes in there. So one example is rolling a 6-sided die. So of the 6-sided die, you could get a 1, 2, 3, 4, 5, or 6. And so like I say, you put in the little braces, and that's how you would write that. Now, luckily for you, I already wrote this ahead of time, but this is rolling a 6-sided die twice. So this would be if the first roll you rolled a 1, then your other options for the second roll, you could have rolled a 1, 2, 3, 4, 5, 6. And then I just went through. So if you rolled a 2 the first time, your second die could be a 1, 2, 3, 4, 5, or 6, and so on and so forth. So if I would have rolled a 5 the first time, then your second die could be a 1, 2, 3, 4, 5, or 6. So when you, all of these options, and it's best to keep organized, so that way you understand how many total outcomes there are. So what you're going to try is you're going to do these two. And it says drawing a marble from a bag with 2 red, 3 blue, and 1 white. So think of all, just any marble from the total bag. So what would be all the options? You would go ahead and you'd list what your sample space is. Now this one says to draw a tree diagram. This is a tree diagram. So it's the branches. You could either have it go like this, and then it branches out more, depending on how many you have, or you could do kind of like if you were factoring, depending on how many you have of each option. So this one's a tree diagram. And then you're going to list all the samples if you roll it 3 times. So it's very similar to this one. You're just doing each one more time. And it's best to keep neat and organized. All right, next up we have intersections and unions of sets. So a universal set includes all the objects. So if you're to look here, this whole thing is E, and that includes all of the numbers. So 0, 9, and then typically we list them in order from least to greatest. So go ahead, put that in there. For set A, we're only looking at this part. That's a horrible circle, but that's okay. And then so even though this part is within another section, this is still all A. So you have 1, 3, 5, 7, 9 are all within a circle A. For set B, this is set B. And for set B, you have 1, 2, 3, 4, 5. And I just listed those as what's in there. Now it's going to be a little bit more because you have the union of set A and B. So when you're looking at this one, you're going to think about what they have in common. So it would be 1, 2, 3, 4, 5, 7, 9. So it would be whatever is in both the circles. So all of here. So we don't want 10, 6, or 8, or 0. So go ahead and make sure you put your answer here. Oops, it looks like I didn't write it, my bad. So you're going to have equals, and then like I said, 1, 2, 3, 4, 5. Oops, and I forgot 7 and 9. because I need these two there. Okay. All right. And then for here, for the intersection, it's just this part. So you have A, and notice when you're doing that, it looks like upside down U, and it's going to be 1, 3, and 5. Oops. That'd be that at the end, and it's just that section. All right. Now complement is abbreviated. It looks like A prime, but it's basically saying the complement of this is everything except for A. So we want everything so this is all A, but we don't want those. We want this right here, and that's what you would write. And then the disjoint set, so again, you're going to have that of S and T. So if you notice, disjointed, there's nothing in common. There's nothing here, so you would just say it's a null set. And then here, there's nothing in common. So since there's nothing here, that's it. That's all you write. And then T is a subset, so that looks like the little U that goes like that with a line underneath it. So T is a subset of E, so T is within E. And then here, we want to know set S is this guy right here. And then set T is here. So we want to know where S subset of T. So all elements of set S are in set T. So when you look here, this is your answer. So you list them out, and if you notice, this is 0, 1, 2 for set S, and that's within set T. All right, so now what I want you to do is this is a Venn diagram right here, and you do have a couple numbers outside, so make sure you're careful with those. You're going to do this problem using the examples we did before. Now on this one, I got you started with some color coding. And it says in a class of 100 students, so all of this should equal 100 total, if we did it correctly. So now, you're going to go through and you're going to figure out, you're going to answer all of these based off of this information here. All right, and then 45 is here, so I color-coded everything with you. All right, so like I said, this is your Venn diagram, and you've got those sections. All right, this one, it looks like a lot because you have 3 of them. So I'll give you a hint of the survey. There's social network. We're given Instagram, TikTok, and Snapchat. So I color coordinated Instagram, TikTok, and Snapchat is here. And if you notice, this little section is where all 3. So what you're going to do is you're actually going to start down here, and then you'll work your way up. That'll be a little bit easier. So all 3 goes here. 10 are Snapchat and Instagram. So here's Snapchat, here's Instagram. So this part where the 2 overlap is supposed to be 10. But since we already have 3 here, that means this section has to be 7. All right, and here it says 9 are Instagram and TikTok. So Instagram, TikTok. Well, where they overlap is here. So if you already have 3, this would have to be 6. And then, because that's both, so 3 plus 6 equals 9. And then what you're going to do is 19 are Snapchat users. So remember, when you've got Snapchat, that's this whole circle right here. Well, you already have 3, 4, 7. So you have to do all of those to get how many is only Snapchat. And then what you're going to do is 26 are TikTok users. So all of this is going to equal 26. And then all of this for Instagram is going to equal 21. So go ahead, you're going to finish that and then answer these questions. All right, so now we have the counting principle and basic property. So basically, different ways of multiple independent events can occur. So what you're going to do is you're going to multiply for each stage of event. So in this case, you want 2 crusts to choose from and 5 toppings available. So we have crust times toppings will give you your total. So in this case, you have 2 crusts, and then for each one, you have 5 toppings. So you multiply them, you've got 10 different ways you could do it. Now, if we were to include two possible sizes, I did crest times topping times sizes, and then that would give you your answer there, which would be 20. All right, so from here I started this for you, and then you're going to finish the rest. So you're getting dressed for school. You have 4 clean shirts, 2 pairs of jeans, and tennis shoes or flip-flops, so that's 2 options there. Assuming you wear 1 shirt, 1 pair of pants, and 1 pair of shoes, how many possible outfits can you wear? So total shirts we have 4, jeans we have 2, and shoes we had 2. So you're going to go through multiply, and you can make 16 outfits. All right, so I kind of helped you out with the last couple, but let me give you a heads up with this one. In this case, it says how many 5-digit codes, so what I did is I wrote the 5 digits here, can be made if you have to choose from the first 10 letters in the alphabet with no letter is repeated. So if you start here, you have 10 options for the first number. And then if it can't be repeated, because we said no repeats, then you're going to have 9 options. And then if we can't repeat, it's going to be 8, then 7, and then 6. So there's 6 options. So this would be 1 through 10. This would be 1 through 9, 1 through 8, 1 through 7, so on and so forth. And you're going to multiply all those together. You're going to get 30,240. All right. So how many codes are possible if the letters are repeated? So in this case, since they are repeated, you have 10 options for each one. So it could be 1111, and then you'll get that, and that's 100,000. All right, so I want you to go ahead and I want you to try these two. And then here we have the basic probability principle. So it's basically total parts over total of whatever the outcome is you're looking for. So if you have a bag filled with 4 red marbles and 6 blue marbles, your total is going to be 10. So total is 10. But we want to know what's the probability of picking a red. Well, since we have 4, it's 4 out of 10 total, which gives you 2/5. And in this case, determine the probability of choosing a blue marble. Well, we said there's 6 blue out of 10 total. So 6 over 10 equals 3/5. All right. Now for this one, I started it for you, but you're going to finish the rest. So it says consider a jar of marbles, and I gave you all the nice little pretty colors here. What's the probability of choosing? Well, first we need to know the grand total. So we have to add all these together. Don't forget that 5 is kind of hiding there. And so we know our total is 37. So we're looking for a red. Well, here we said there's 8 red out of 37 total. And then that would be it. So that's your options. Now, here it says a green or a white. So we have 10 green and 5 white. So to get a green, the probability would be 3 or 10 over 37. And to get a white, although it's kind of gray, I couldn't write white on this, would be 5 out of 37. So make sure you got a common denominator, which we do because we have the same total. And you're going to add the 2 to get 15. So you have a 15 out of 37 chance of picking either a green or a white. So remember, you're going to add it on those. So what you're going to do is you're going to finish these. And then here, consider rolling 2 6-sided dice, 36 possible outcomes. So of this, there are 36 options. And we want to know what's the probability of rolling a sum of 10. Well, a sum of 10 means you're adding the 2 digits. So here, 4 plus 6, 5 plus 5, and 6 plus 4. So that's 3 options out of 36 total. And then, of course, you can simplify that to 1/12. And then for number 5, you have a 2 and a 3. So it has to be both. So this one is a 2 and a 3, and this is a 3 and a 2. It didn't say what order, as long as you've got a 2 and a 3. And there's no other options. So you have 2 out of 36 total, which gives you 1/18. All right, so you're going to go through, you're going to do this one, you're going to do those two, and then of not rolling a 1. So again, if it helps you kind of color code or check them as you're doing it, go ahead and do that. All right, and then that's a lot of information, so make sure you finish all those notes that we didn't get a chance to do, and you go ahead and make sure you know all the vocab, what set theory is, how to work Venn diagrams, counting principle, and then your basic probability.